Hello Jiwaku. In this video, we will show you the case study of Muara Labuh geothermal field using Jiwa TOR. In this case, we will try to evaluate the Muara Labuh geothermal field top of the reservoir interpretation to the actual top of the reservoir. Stay tuned. The Muara Labuh geothermal system is situated within a pull-apart basin along the northwest-southeast Great Sumatran Fault, approximately 135 km southeast the capital city of Padang, West Sumatra Province. The field is also associated with the Quaternary to recent active volcanic arc of Barisan Mountains Range. Reservoir rocks range in age from Plio to Pleistocene to late Cretaceous. Alternating sequences of andesitic lavas and tuff and silicic ash flow tuffs and related deposits filled an expanding tectonic basin that formed in a right step over of the Great Sumatran Fault. The developer reservoir has moderate to high temperature of 230 until 310 degrees Celsius. The input parameter used in Jiwa TOR are well ground elevation, base of conductive elevation and temperature, reservoir temperature from the geothermometer, boiling chloride spring elevation, and distance from the targeted well if these data are available. Those data are collected from reputable sources. Now we are going to evaluate one of the wells in Muara Labuh field named MLX well. In order to be able estimating top of reservoir in Jiwa TOR, we have to know the well ground elevation since the output we want is the tar depth estimation. MLX is estimated to be located at 1,420 meters above sea level. After that, we are going to input VOC parameters which include VOC elevation and VOC temperature. How do we know these informations? In previous video, we have learned that the base of conductive elevation can be delineated from the resistivity model, either resulted from the inversion of magnetic fluidic or MT or tension electromagnetic or TEM method, or both of them. VOC elevation is interpreted by the low resistivity anomaly of 5 until 10 ohm meters that correlates to the SMACTA cap. From the resistivity model, the VOC elevation below the well MLX is around 750 until 800 meters above sea level. In this case, the VOC temperature is assumed to 180 until 220 degrees Celsius. You might be curious, why do we use this assumption? You can check another anime video which particularly explains about this. After that, we can go to the reservoir field parameters and choose what type of surface manifestations data that access. In this case, we are going to use the boiling chloride spring information from Sapan Malulong. The various geothermometer temperature result in range of temperature at around 182 until 202 degrees Celsius. The estimated reservoir temperature from the boiling chloride is extrapolated in Jiwa TOR using a horizontal geothermal gradient, usually 5 until 15 degrees Celsius per kilometer, based on the field experiences. The extrapolation is needed to predict a possible reservoir temperature that will be found in MLX. After that, we can run and see the result of Jiwa TOR. This is the result of the well MLX top of reservoir using Jiwa TOR. The Jiwa TOR estimation result of well MLX shows the top of the reservoir uncertainties at around 100 meters. Next, let's try to compare with actual well data. In this case, the actual TOR information is collected from the updated conceptual model of the Muara Labuh field. The updated conceptual model shows the natural state based on measured well data, relevant geological and physical information. From this conceptual model, the top of the reservoir is expected around 750 meter elevation above sea level, which is correlated with P50 of Jiwa TOR estimation. It indicates that the actual TOR is situated at the range of the Jiwa TOR system estimation. In conclusion, Jiwa TOR can be applied to the liquid-dominated geothermal system such as Muara Labuh field. The actual TOR of this geothermal field is situated in the range of Jiwa TOR estimation. that's all the case study of QR interpretation in the liquid geothermal system using GWAT-UR. What do you think? Are you still curious with other case studies? Or do you want to learn another geothermal topics? Stay updated and keep watching our next videos on GWAT channel. See you!